Okay, so today we're going to look at we're looking at energy resources, along with different types of energy resources. Let me get back to school. So, 16. All right, so in the Monday folder, here's our notes. Everybody should have done the bell ringer. For the bell ringer, it was asking, what do you think is better to use? Renewable or non-renewable, and I can just tell you when I'm looking at y'all's, most students today have said renewable, and that's good because it's good to have a diversity of different types of energy resources that we use. However, what I will say is that at this point, if we had to rely solely on renewable energy resources, it probably we wouldn't make it too far. In other words, we'd start running out of energy. With modern day society, we are very energy dependent and we use a lot of high energy fuels. So today we're looking at renewable versus non-renewable, or I should say this week. And one thing you should learn this week is some of the advantages and disadvantages of different energy resources. Do y'all know what these are back here on my screensaver? No? Those are oil rigs, okay? Oil rigs out in the ocean. If you ever been to the beach, y'all been to the beach in Corpus? Been to the beach? No? All right, if you go to the beach down in Corpus and you look out in the ocean, way, way out on the horizon, you'll see these oil rigs. You can actually see them from the beach. They're very small because they're miles and miles away. I'll say they're extremely large, but they're very hard to see because they're miles and miles away. And they're a lot easier to see at night because at night you can see the lights blinking on them. So at night you'll see just lights blinking. What these things do is they drill down into the ocean and they get oil from the ocean. Some disadvantages of oil rigs is they actually can pollute the water. What happens is when they're drilling for oil, these things will leak oil, and that oil that gets leaked ends up in the water. So a disadvantage of an oil rig is pollution. About 10 years ago, there was a Deepwater Horizon was the name of it. It was a big oil rig off of Louisiana, and it had an explosion and ended up leaking millions of barrels of oil into the water. It went on for weeks and weeks, and the theory when it happened was that the Gulf of Mexico was going to be destroyed for decades to come. In other words, it'd just be full of nasty oil and pollution. And interesting enough, it was bad for the first year or two, but it quickly began to correct itself. And what happened was because the Gulf of Mexico naturally leaks oil into the ocean. So there's a lot of oil trapped underground in the Gulf of Mexico, and it leaks up to the surface just by natural processes. And what has happened is bacteria has actually evolved to eat that oil. So as a result, after a couple of years, most of that oil seems to have just disappeared because bacteria ate it. Or at least that's kind of the theory of what's going on. But with that being said, we're looking at energy resources like fossil fuels versus renewables. And why am I having such a hard? There it is right there in front of me. That's what I'm looking for. Okay, so the first one is fossil fuels. Which by the way, these are notes. If you want to get out your notebook and take notes, it's up to you. Or these notes will be available for you. Fossil fuels are high energy substances formed millions of years ago from plants and animals. Fossil fuels include petroleum or oil, natural gas, and coal. Interesting thing, kind of losing my train of thought. I guess what I meant to say is that they are high energy. That's very important. What that means is I can get a gallon of gas. I have a car that gets 50 miles to the gallon. It's one of those hybrid cars. I can take a gallon of gas, put it in my car. I can drive 50 miles. I can drive from one side of San Antonio all the way over to the other. I could not do that with a battery that was the same size. If I had a battery the same size and I tried to drive across San Antonio, the battery would die halfway across. So fossil fuels have a lot of energy stored into a very small part. Another advantage of fossil fuels is they're very portable. You can put them in a can or a gas tank and haul them around with you. With electricity, you can't do that. You can't plug your car into the wall and go driving around. You have to, store it on something like a battery. So, when I was working on my graduate degree, one semester I had to choose something to study, so I chose energy resources. And from my research, basically what I determined was, from articles I was reading, is we probably have about 20 years of oil left. In other words, gasoline. And what will happen is we're not going to run out of oil or gasoline in 20 years, but it will just become more and more expensive till it gets to the point that it's so expensive that it's not worth, buying a car. If you're going to spend $100 for a gallon of gas, then all of a sudden owning a car becomes obsolete. So my theory is, and actually some of the theories that I've read, is that over time, it just becomes more and more expensive until you eventually have to find another source of energy. So natural gas is a byproduct of oil, so it'll probably follow about the same path. However, coal, we have about 150 years of coal left. North America is known as the Saudi Arabia of coal. Saudi Arabia has a lot of oil. North America has a lot of coal. The problem with coal is, so that's an advantage. If we have a lot of it, we're not going to run out anytime soon. The problem with coal is it's very bad at polluting. When you burn coal, it releases a lot of pollution into the air. Fossil fuels are fuels that are made from dead animals. Most people think of dinosaurs, which is not necessarily true. Hundreds of millions of years ago, the theory is animals that lived in the ocean died and fell down to the bottom of the ocean. And more than likely, we're not looking at big animals like fish. What we're looking at is things called zooplankton and zooplankton, little microscopic animals that live in the ocean, and plants. And as they die, they fall down to the bottom of the ocean, and they get layered and layered and layered, and eventually are baked under high heat and pressure into oil. The way coal is made from dead trees and plants. And the theory is dead trees and plants that live in very moist areas, like a marsh. They die, and they end up getting buried, and over millions, if not thousands, if not millions of years, they turn into first peat, which is something you can dig up and burn. And then lignite, which is a cheaper version of coal, and then coal. Again, this takes millions of years to occur. That's why they're called fossil fuels, because it's from things that live way in the past. In this case, plants. This is a coal mine. It's very dangerous, very hard work. They can be up to a mile underground. The coal mines can actually explode because this coal is combustible. It will burn, and it forms a fine powder when you're trying to dig it out, and that powder can explode. It's also very bad for your lungs. This guy's not wearing a mask. He's probably going to die a very young death. In other words, he probably won't live much past 30 or 40. Coal miners get what's called black lung, and it's from the tar dust gets in their lung, and eventually just can't breathe very good. This is a strip mine. Strip mines are a lot safer and a lot cheaper than coal mines. However, they do a lot of environmental damage. I've actually flown over them in airplanes, and you can see where they've taken an entire mountain. And you got to realize how big a mountain is. They'll take an entire mountain, they'll just plow the top of the mountain off, and exposed beneath is the coal. So that's a strip mine. Okay, then we have a coal burning power plant. This is what we use, most of the coal gets used for. It gets used for boiling water to make electricity, and what most people don't realize is that's the way most electricity is made. Most electricity is made by boiling water. In this case, they burn coal, which boils water, turns the turbine, makes electricity. All right. Fossil fuels are known as non-renewable. The reason they're a non-renewable resource is because they are not replaced when they are used. Once you use them, they are gone. You can't replace them. So this includes fossil fuels and rare earth metals, things like uranium and plutonium that we use for nuclear energy. Renewable resources are resources that are constantly being resupplied, such as biomass. Biomass are plants and animals. So, for example, you cut down a tree, you grow a new tree. It's renewable. Or wind energy. Okay, you can't use all the wind. In fact, wind energy is actually wind energy and solar energy are what's known as inexhaustible, which means you can never run out of them. However, you will hear inexhaustible and renewable used interchangeably. So a lot of times people will say that wind energy is renewable. Okay, well, no, not necessarily. It's actually technically inexhaustible because we will never run out of it. So solar and wind. So if inexhaustible resources like sunlight can be used for energy, then why don't we just use sunlight instead of fossil fuels? Well, there's always issues. For example, with solar panels, does the sun shine at night? No. Okay, the sun does not shine at night, so what do you do at night if you have a refrigerator running? You can't just turn your refrigerator off all night. Well, one thing you can do is you can get batteries. So during the day, you run your refrigerator off the solar panels and you charge your batteries. At night, you use your batteries to run your refrigerator. Well, the next issue, what if it rains for a week or 2 weeks? You can't just let your food sit there in the refrigerator with no refrigeration for a day, much less a week or 2 weeks. So there's issues like that. Not just that. Solar panels are electric solar panels, the ones that turn sunlight into electricity, are extremely expensive. You will see them on the roofs around Jordan Middle School. Some of the houses around here have them. But what you have to realize is that those are subsidized by the government. So, for example, a person will pay 1/3 of the cost, the government pays the other 2/3. If the person had to pay it by themselves, they would never do it because they can never make the money back. You'd have to be rich to decide to do something like that, which most people are not. They can also use up a lot of land. This is a giant solar panel collection facility. These are starting to pop up around San Antonio. Another disadvantage of solar panels is they actually wear down over time. So they may be very efficient at first, but as time goes on, they become less and less efficient. All right, so that's solar. So going back to it, where do we leave off? All right. Okay, so then we have what's called a sustainable resource. Sustainable resources can last forever, however, you have to take care of them. For example, a forest. Okay, so say we're cutting down trees to burn the trees to make electricity. Well, can we cut down all the trees? Yes. In modern day society, with the type of equipment we have, we could very easily cut down all the trees in a forest. So you have to do what's called sustain them. It's a sustainable resource. So you don't cut them down all at once, you rotate them. And actually, if you go to Washington State, and you drive through that area, you'll notice that the trees are actually layered. You'll drive for a few miles, there's nothing but a bunch of little 5-foot trees. And then you'll drive for a few more miles, and all the trees are 50 feet tall. Drive a few more miles, all the trees are 100 feet tall. What's happening is instead of cutting down all the trees, they cut down some and plant some babies. And they'll go on to the next section. And they'll come back 50 years later. And 50 years later, when those baby trees have grown back up into big trees, they'll cut them down again. So that's a sustainable resource, something you can take care of. Then there's the term conservation. Conservation means to save. So if saving something is to save something is to conserve something. All right. Pollution is anything harmful. I think most of y'all know what the term pollution means. However, probably what you don't realize is all the different types of pollution. There's water pollution, air pollution, soil pollution, thermal pollution, radioactive pollution, noise pollution, and light pollution. Thermal pollution is heat pollution, and where it comes from, for example, would be a nuclear power plant. With nuclear power plants, they have to keep the power plant cold or cool off. It will get so hot that it will actually melt through the building. So they have to constantly run water over it. And what that does is they use water from a lake or a river, and after they're done, it gets dumped back into the lake or river. That actually can cause, it can actually kill fish, because when the water is warm, it cannot hold a lot of oxygen, and as a result, the fish can't breathe. Then you have noise pollution. There's a lot of animals that are not going to live around a lot of noise. For example, you don't see a lot of deer walking around the neighborhoods here because, they like a little more quiet than what we have around here. So certain animals are a lot more sensitive. All right. And then we have light pollution. I grew up in San Antonio. When I was a kid, I lived on the outskirts of San Antonio. When I was a kid, you could see the Milky Way. The Milky Way is a bunch of stars up in the sky that make one of the arms of our galaxy. And it's called the Milky Way because it looks like a cloud. Somebody, I guess, decided it looked like milk up in the sky. And actually what you're seeing is trillions of stars. When I was a kid, you could still see the Milky Way in San Antonio. Because San Antonio is so big now and there's so many lights, all the lights of the city basically drown out the stars. You can't see nearly the amount of stars you used to be able to see. So light pollution. Then we have acid rain. Most students, when they think of acid rain, they think of something that will burn you, and that's not necessarily so. With this acid rain is actually a natural event. Rain is naturally a little bit acidic. It has some carbon dioxide in there that forms carbonic acid. It's not going to burn you. You can get in your eyes. It's just natural rain. When you eat a lemon, the reason a lemon tastes sour is because it has a high level of acidity. It has a lot of acid in it. Water's a lot lower, I should say rainwater. However, if you burn a lot of fossil fuels like gasoline or you're burning coal for energy, that can mix with water vapor in the air and form acid rain. It will, over time, kill forest. Okay, this is not something that has, these trees were killed by acid rain. It's not something that happens by one rain event. What happens is month after month, year after year, the soil becomes more and more acidic until finally the trees can't live in it. All right, then there's biofuels or biomass. Biofuels are fuels made from organisms. For example, cutting down trees to burn to heat your house, in other words, a fireplace, or cutting down trees to boil water and make electricity in a power plant, or using corn to make gasoline. What you can do is you can corn, sugar cane, what's called sugar beets. You can actually ferment them. You can ferment corn into alcohol, and you can put that alcohol in gasoline. Right here where it says 10% ethanol. Ethanol is made from corn. So they take corn, they grind it up into a mash, and they make alcohol out of it, and they put it in your gasoline. I'm actually not a big fan of this. Big reason, it destroys your engine. It has a lot of, what happens is the ethanol, the water will separate from the ethanol and cause rust. So biofuels are, some other examples are trash that they can burn for heat. They can actually trap gas from the rotting trash. So when you throw your trash away, like your kitchen trash, and it goes to the landfill, that trash rots in the landfill. And as it rots, it puts off gas. So they can actually trap that gas now and use that gas for fuel. Okay, here are some examples of biomass: garbage, crops, alcohol, and wood. An interesting thing, when you make electricity from firewood, you do the exact same way as you use coal. You burn, make a fire, you boil water, and that boiling water turns a turbine. Okay, then there's geothermal energy. Geothermal energy is energy from the earth. It is the cheapest way to make electricity. However, it's very rare. You have to have earth that's very close to the surface. I should say you have to have very hot earth that's very close to the surface. So, for example, like Wyoming has a lot of volcanoes and geysers. That's kind of what we're looking at. We're looking at areas that have magma or lava very close to the surface. Iceland is actually the one country that uses a lot of geothermal. They make 90% of their electricity from geothermal energy. All right, then you have hydropower. Hydropower is when you use gravity or the kinetic energy of water to make electricity. So in this case, you're just using the water cycle, in other words, rain, and you trap it high up in the hills, and the gravitational potential energy turns the turbine, which makes electricity. All right, so that's basically what we're looking at this week. We're going to look at the advantages and disadvantages of fossil fuels and renewable energy. My plan is probably near the end of the week, you'll do a little research project where you're finding advantages and disadvantages. With that being said, let's watch a video. If I can find it.
Distance has been on all of our minds lately. That we've been too close to something.
What lights up the screen that you're looking at right now? Trace back the battery chargers and power cords, and you'll end up at an electrical outlet, providing easy, safe access to reliable electricity. But beyond that outlet, the picture gets messier. It takes a lot of fuel to heat our homes, preserve our food, and power our gadgets around the clock. And for 40% of the world, that fuel is cheap, plentiful, and it's called coal. But coal also releases pollutants into the air, like sulfur dioxide, nitrogen oxides, soot, and toxic metals like mercury. These cause environmental damage like acid rain and serious health problems. In fact, in 1952, coal burning caused such heavy smog in London that pedestrians couldn't even see their feet, and thousands of people died from ill health. Since then, many countries have deployed technology to remove most of these pollutants before they reach the air. But now we have a new air pollution problem on our hands, one that doesn't show up in a cloud of dark smog, but in rising seas, floods, and heat waves. It's global climate change. And again, the main culprit is coal. It's responsible for 44% of global carbon dioxide emissions, which trap the sun's heat in the Earth's atmosphere instead of letting it escape. So now the question is, how do we remove that bad stuff as well? That's the idea behind cleaner coal. Creating cleaner coal is really about trying to contain its ill effects with the help of special technologies that make the end product more acceptable. Just like the most intriguing superheroes often have their own dark powers to overcome, so we can try and keep coal's negative forces in check. But why don't we just exterminate coal if it takes that much effort to clean it up? Simply, coal is extremely valuable to us, and it's easy to come by. Compressed underground for ages, coal holds chemical energy from plants that were fed by the sun hundreds of millions of years ago, long before humans evolved. That makes coal energy dense, meaning it can be burned round the clock. It's also cheap if you ignore the pollution costs, and should last us through the end of the 21st century. We've already got all the infrastructure in place for harnessing its power. And globally, although countries are making a move towards energy from cleaner and more renewable sources, there's no sign yet that coal use is slowing down. In fact, as of 2012, Over 1,000 new coal plants have been proposed, mostly in China and India. Since, for the time being, coal is here to stay, experts say that if we want to reduce its emissions impact on the atmosphere and slow down climate change, we'll have to think of creative ways of reducing coal's destructive power. To do that, we need to strip it of its foul forces, all that toxic carbon dioxide that causes havoc in the atmosphere. Then we need to store this CO2 somewhere else. This mission is called Carbon Capture and Sequestration, or CCS. And as if carbon dioxide were some evil genie we didn't want to escape, once it has been separated from coal, we've devised ways to banish it underground. We can do this by injecting it deep into the earth, or by placing it deep under the ocean surface. Stripping away coal's negative elements can happen in three ways. First, and most commonly, as coal burns, the exhaust gas can be mixed with a compound called monoethanolamine. Like a forceful power-stripping magnet, this compound bonds to the CO2, yanking it out of the gas stream so it can be stored separately underground. Another method is to relieve coal of its CO2 before it even has a chance to be released as exhaust. In this process, steam and oxygen swoop in to the rescue to convert coal into a special product called syngas, made up of carbon monoxide and hydrogen and some CO2. Zap that with some water vapor, and the carbon monoxide gets converted into carbon dioxide, which can be isolated. The leftover hydrogen gas is then used as energy to generate electricity, so there's an added bonus. A third technique exposes coal to pure oxygen instead of burning it in air. This creates exhaust gas with higher concentrations of carbon dioxide, which makes it easy to isolate and to banish to the chasms below. All this can reduce emissions at a power plant by up to 90%. But as with any superhero struggling with their destructive powers, it takes a lot of effort to switch over from the dark side. So these positive pollution-busting forces, although they're available, have barely been used in commercial power plants because they cost a lot. But ultimately, the bigger problem is that in most parts of the world, it's still too easy and much cheaper to keep emitting carbon dioxide. And that makes it tempting to completely ignore coal's dark side. In this case, the most powerful force for good is regulation. The rules that can restrict the amount of carbon dioxide emitted from power plants and make energy companies around the world wary of what they put into the air. Until then, every time you turn on a screen or flick a light switch, coal is lurking in the background, carrying its dark powers with it wherever it goes.
All right, and that's it for today. We're going to do a few things tomorrow. I actually need to get ready for my next class because I've been having issues with Zoom, so I got to kind of boot everything up. So I'll see y'all tomorrow. Have a nice day.